This is Chemistry Example 11.3. The problem reads, a mixture of gases contain 3.0 moles of oxygen gas, 5.0 moles of nitrogen gas, and 1.0 mole of neon gas. What is the mole fraction of each gas in the mixture? Okay, so what we have to remember is what is a mole fraction. A mole fraction is essentially a measure of the concentration used in context of the entire mixture. In other words, a mole fraction, which is abbreviated X, is equal to the number of moles of the compound or the gas that you're interested in per or divided by the total number of moles in the entire mixture. So it's giving you kind of the concentration of a specific compound or gas in context of the entire number of moles that are involved in composing or making up that mixture. And so if we write down what gases are present in our mixture, in the problem we find out that we have oxygen, nitrogen, and neon gases in our mixture. And we know how many moles. And remember, moles is the number of molecules that are present. So for oxygen, we have 3.0 moles. For nitrogen, we have 5.0 moles. And for neon, we have 1.0 mole. All right. And so that kind of takes care of, in this equation, we know the number of moles of each compound. So it leaves us to determine what is the total number of moles in this mixture. And this is relatively straightforward, right? It's just the total. If this is all that there is, we simply add up each moles of each of those compounds. So 3 plus 5 plus 1 equals 9. So our total mixture is composed of 9.0 moles of gas. And so if I want to know the mole fraction of oxygen, and we abbreviate that X with the subscript oxygen, or O2, we would set that equal to the number of moles of oxygen that are present, and that is our 3.0 moles, and we're going to divide that by the total number of moles present in the mixture, which is 9, and that will give us 0.33. Notice that this does not have a unit because the moles will cancel, so this is a dimensionless or unitless value. All right, so the mole fraction, in essence, this is saying about 1/3 of this entire mixture is made up of oxygen gas or moles. Okay, so then we look at nitrogen. We know that we have 5.0 moles of nitrogen present. We know that the total number of moles in our gas mixture is 9.0. And so if we do that division, and we get 0.56. So a little over half of our gas mixture is made up of nitrogen gas. All right. And for neon, so X represents our mole fraction, subscript neon, which is Ne. Sorry about the legibility there. And we know from our problem that we have 1.0 mole neon in our total mixture of 9.0 moles. And that division gives us 0.11, or a little over 1/10 of this mixture is composed of neon gas. And that's really all there is to this problem. You just got to recognize what the question is asking for. Make sure in each of these word problems you can identify what is known versus what you are looking for, and then of course choosing which equation that you need to use to determine the answer. And that's all there is.